Hi students, today we are going to discuss the topic elastic collision in one dimension. Suppose if we consider two different bodies of masses m1 and m2, they are moving along the same straight line before collision. After some time they are going to hit with each other. After collision they get separated and once again follow the same path. Then such a collision only is called as what? One dimensional collision. If during this collision kinetic energy is conserved, that means if there is no loss of kinetic energy, then such a collision only is called as elastic collision in one dimension. So now you look at the picture here, there are two different masses m1 and m2. Initially they are traveling with the velocities u1 and u2 respectively before collision. So what is the total momentum of the system? m1 u1 plus m2 u2. Then after a few seconds they are colliding with each other. They are coming into contact. After the collision, once again they are moving along the same straight line with different velocities v1 and v2 respectively. That is after collision. So children, now in any type of collision, irrespective of whether it is elastic or inelastic, the first physical quantity that is to be conserved is the linear momentum. Linear momentum will be conserved. So here conservation of linear momentum. First we will discuss conservation of linear momentum. That means the total momentum before collision must be equal to the total momentum after collision. So the total momentum is m1 into u1 plus m2 into u2. Okay. So this is before collision. So after collision, what is the total momentum? m1 v1 plus m2 v2. So this is m1 v1 plus m2 v2. So now the mass of the first body I will shift to the left hand side and the mass of the second body now m2 I will shift on the right hand side. So this equation becomes m1 u1 minus of m1 v1 and this must be equal to m2 v2 minus m2 u2. Then again grouping of terms. m1 is a common factor, is it not? So I can write the same equation in a different form. That is m1 taken as common factor into u1 minus v1. This is right hand side m2 is the common factor into v2 minus u2. And I call this as equation 1. Okay. So equation 1 we have derived on the basis of law of conservation of linear momentum. Since this collision is an elastic collision, in addition to the linear momentum, its kinetic energy also will be conserved. That means the total kinetic energy before collision must be equal to the total kinetic energy after collision. So the kinetic energy of the system before collision is based on a conservation of kinetic energy. So the total kinetic energy before and after collision will be the same. So I will write half into m1 u1 square. This is the kinetic energy of the first body before collision plus half into m2 u2 square. So this is the total kinetic energy before collision. Okay. And this must be equal to what? Half m1 v1 square plus half m2 v2 square. So this 1 by 2 can be cancelled on both sides. Once again grouping of terms, all m1 terms on the left side and m2 terms on the right side I will shift. So that here m1 u1 square minus m1 v1 square. This must be equal to m2 v2 square minus m2 u2 square. Okay. Now which factor is common on both sides is m1 on the left side and m2 on the right side. So I can rewrite this equation as what? m1 into u1 square minus v1 square This is equal to m2 into v2 square minus u2 square. Now I call this as equation 2. So equation 1 is derived on the basis of conservation of linear momentum, and equation 2 is derived on the basis of conservation of kinetic energy. Okay, now I am going to divide the second equation by the first equation. What for? I want to derive the expression for the final velocities after collision, that is v1 and v2 in terms of u1 and u2. This is for solving the numerical problems. So in this final derivation is what we have to get the expression for the final velocities v1 and v2 in terms of u1 and u2. That is why I am going to divide the second equation by the first equation. So equation 1 divided by equation 2 on both sides. So the left hand side of the second equation is what? m1 into u1 square minus v1 square. So this is u1 square minus v1 square divided by the left hand side of equation 1 is m1 into u1 minus v1. And the right hand side of the second equation is m2 into v2 square minus u2 square divided by the right hand side of equation 1 is m2 into v2 minus u2. Okay, so this m1 and m1 get cancelled, m2 and m2 get cancelled. Then on the numerator, this is a square minus b square format. So a plus b into a minus b form I am going to write. So this same can be written as a u1 plus v1 multiplied by u1 minus v1 divided by u1 minus v1. And this must be equal to what? Right hand side is a square minus b square format. Once again, if I will expand this, so this is v2 plus u2 into v2 minus u2 whole divided by v2 minus u2. Now you can see some terms get cancelled. See here u1 minus v1 and right side v2 minus u2, they get cancelled. Okay, therefore what is remaining? u1 plus v1 is equal to v2 plus u2. Or I can write v1 is equal to, okay, I will get v1 is equal to v2 plus u2 minus of u1. This is the required equation number 4. Suppose here if you want to retain v2 and bring this u2 to the other side, then what is v2 is equal to? v2 is equal to v1 plus u1 minus u2. So this is our equation number 5. Okay, but we want to get an expression for v1 only in terms of u1 and u2. There should be no v2 term, is it not? Therefore what we are going to do is we can substitute either fourth equation or fifth equation in the first equation. Suppose in the first equation you substitute for v1, then you will end up with an expression for v2. Suppose if you substitute v2 for this first equation here, v2, then you will end up with the derivation for v1. Okay, so now let us substitute this v2 I will substitute. So what is v2 is equal to? v2 is equal to v2, see here, v2 is equal to u1 plus v1, so minus u2. This equation I am going to substitute in the first equation. Okay, so I will write substitute. It is our choice only. You can substitute either the value of v2 or v1 also. Okay, so substituting 5 in equation 1. Okay, now let us start the left hand side, m1. So this is m1 into v1, sorry, u1 minus v1. So u1 minus v1 is equal to m2 into v2 minus u2. This is the actual first equation I have written. So equation for v2 I am going to substitute, is it not? So the right hand side is now equal to m2 into What is V2? V1 plus U1 minus U2. So I will write V1 plus U1 minus U2. Then one more minus U2 is here. So this minus U2. So carefully we will have to substitute, okay, without missing the terms. And this is now equal to what? M2 into V1 plus U1 minus 2U2. Now I will open up the bracket on both sides, okay. I am going to open up the bracket so that now first term is what? M1 into U1. Minus second term is M1 into V1. The right hand side first term is what? M2 into V1 plus M2 into U1. M2 into U1 minus 2 into M2 U2. M2 U2. Okay. So now we have substituted for V2. That is why we are getting an expression for V1. So I am going to group all the V1 terms on one side. Okay. So this V1 and V1 term on the right side I will take, or on the left side also we can take. So first I will shift the terms as it is here. M1 U1 is here. Then minus M2 U1 minus M2 U1. And this is minus brought on the right left side is now plus 2 M2 U2. This is equal to M2 V1. So this is M2 V1. This minus is shifted to the right side as plus. So this is M1 into V1. So we have shifted the terms. Now we are going to get an expression for V1 by taking V1 as a common factor. Is it not? Now I am going to erase the first step. Okay, first equation. See, this side I am going to erase. Okay, children, now I am changing the sides so that M2V1 plus M1V1 on the left hand side. So this is M1V1, M1V1 plus M2V1. Okay, this is shifted on the left hand side. Right hand side, what are the terms? M1U1 minus M2U1. So M1U1 minus M2U1. Plus 2M2U2 plus 2M2U2. Okay, now on the left hand side V1 is a common factor. So V1 into M1 plus M2. This is equal to here U1 and here U1 is there. So I will write U1 into M1 minus M2 plus 2M2U2. Okay. So like this I can write. I need an expression for V1, is it not? Okay. Therefore, V1 is equal to U1 into M1 minus M2 plus 2M2U2 whole divided by common denominator is what? M1 plus M2. So this is the expression for V1 we have derived. So if you want to derive an expression for V2, then here you should have substituted for V1. Okay. So if you substitute for V1 here, then you will land up in equation V2. So from this itself we can write like this. Okay. Similarly, if you derive for V2, here instead of U1 you will get what? U2. And here M1 minus M2, instead of that you will get what? M2 minus M1 plus here 2M2U2 means here you will get 2M1U1. Understand? But the denominator is common here also. The sum of the masses M1 plus M2. So this can be called as equation 6 and this can be called as equation 7. So these two equations are very much required for solving problems in our textbook exercise and also in the IIT, JEE and NEET exams. So my dear students, how to derive the equations for V1 and V2 in terms of U1 and U2 in addition to the mass M1 and M2 also. So the first step is we have started this from the first step, that is law of conservation of linear momentum. total momentum before collision is equal to the total momentum after collision. That is the first step. Second step is what? Law of conservation of kinetic energy. Okay, total kinetic energy before and after collision must be the same. From that, we got the expression for V1 and V2. Again, we substituted them in the equation 1 and we have derived the final equations for V1 and V2. Now there are so many special cases. That special cases of this collision now we will see in another video. I hope you must have understood well. Fine.